Well, welcome back to our Cisco Certified Design Associate Bootcamp here at INE, and we are ready to enter Module 2. And in Module 2, we want to take a look at some modular network models that Cisco provides for us. Again, Cisco is giving us more great assistance with our own construction of this intelligent information network that we're going to strive to achieve. So, thanks to Cisco's assistance on these modular network models, let's take a look at just how these models are going to help us achieve the IIN. Network models that we're going to look at are primarily two here in this particular chapter. We're going to first, right now, in this very lesson, we're going to first take a look at a classic model that Cisco has been teaching for over a decade. So first, we'll start by looking at a real classic model that they've had. It's called the Cisco Hierarchical Network Model. And I'm very proud to say it took me about a decade to learn how to say hierarchical. So it's really good that this network model has been around for a long time because, again, I can now pronounce it. This hierarchical network model is great, but Cisco definitely expanded dramatically upon this basic model, and that's what we'll look at in Lesson 2 of this chapter. We'll go ahead and take a look at the new and improved enterprise architecture model. But before we look at the enterprise architecture model, we'll want to look at this classic hierarchical model from Cisco. First of all, they created this years and years ago because they wanted to make the construction of intelligent information networks easier to understand. By the way, there wasn't really the concept of the intelligent information network a decade ago, but Cisco was always trying to make, obviously, networks that were efficient and that were cost-effective and things of that nature. So they were always thinking about, all right, you making sure you were spending your money wisely in the network infrastructure. They wanted things to be modular. I mean, it is so important that we break things down into building blocks, especially when we're talking about very, very complex things. I mean, the example that I always give to students, and I apologize if this is the 10th, 20th, 30th time you've heard me give this example, but, it's just something that I'm always reminded of when I talk about building something really complex like an intelligent information network and how difficult that would be. Making things modular. My father he builds homes. He's pretty much retired now, but that's certainly what he did for 40, 50 years of his life. He built homes or remodeled portions of homes. And it amazed me to look at one of his finished homes. And I was just like, boy, oh boy, that's remarkable that he built that house. And I just can't believe my father would be able to do that. I mean, I can't believe anyone would be able to do that for that matter. And when you realize that it's done in a modular fashion, like first the foundation is constructed. And you look at the process of the foundation and you realize, oh, okay, that really wasn't that bad. Then they'll come in and they'll frame the house, won't they? So they'll come in and they'll do all this framing of the home. And in fact, that was always my favorite part to help out with, was the framing of this house that was being constructed. So my father, as brutal as it was sometimes because I would make so many mistakes, he'd let me go in and engage in the framing. And then after the framing, and forgive me if I'm getting this wrong, it's been a long time, but then the electrical circuitry gets run throughout the house. And that's a module of the construction of this house, running the electrical circuitry. And then, the next module of the house's construction comes in. And it's just amazing because when you break it down into these modular components, well, it's really, really not all that unfathomable that you're going to build this house. And obviously, you've got teams of people that are specialized in certain things. Like my father could do basic electrical work, but he had his electrician come in, obviously, to take care of that electrical module. So this modular approach really, really helps make things simple. And by the way, when there needs to be modifications, it's more easily modified. And in pure networking terminology, this hierarchical three-layer model that we're going to see allows for, facilitates, encourages the use of summarization, and also makes it easier to track down faults in the network. Now, summarization is really something that we're going to strive for throughout our designs. And why we strive for summarization is the fact that not only are we going to have smaller routing tables, but what also happens with summarization is we have what we call smaller convergence domains. Smaller convergence domains. Here's what can happen. We know, like in an OSPF design, and we'll be studying this in great detail, in OSPF we have this area 0, that's the backbone area. And then we can go ahead and create a non-backbone area like area 10. What you can do with OSPF, it's very conducive to this, it was designed for this, is you can go ahead and summarize the area 10 networks into the backbone. And then into some other area like area 20 out here, the summaries will be propagated, okay, of the area 10 information. And everybody immediately looks at this and they go, oh yeah, cool. That means a routing table on some router, let's say R6, that means the routing table is going to have fewer entries in it. So the routing tables on devices will be smaller, and this is the main benefit that we get with this summarization. But there's another very powerful benefit. Let me put some numbers to this. If we're advertising the 10 summary, okay, into the backbone, then into area 20. So we're saying, hey, look, the only place we've used the 10.x subnets is in area 10. If that's one of the summaries we send, and something happens in here to the 10, 10, 10 subnet, this information doesn't have to be communicated into all of these other domains, right? So this is called reducing the size of our convergence domain. This is reducing the size of our convergence domain. So when there is some change, some prefix adjustment, it doesn't necessarily have to be advertised to the whole world when we're summarizing, and this can dramatically lead to efficiencies in the implementation. Imagine, I guess a better example of a downed network would be an example of, imagine if inside area 10, we've just kind of relocated where area 10, 10, 10, 24 is. Yeah, well, if we've revamped how you get to the 10, 10, 10, 0/24 network in area 10, again, we don't have to tell the backbone, we don't have to tell area 20. They know that they just got to send their traffic into area 10, and that'll take care of it. So a much better example is when we kind of revamp the network inside area 10. Because of the summarization, we don't need to tell anyone. So the hierarchical model promotes network summarization, and this is a great thing. Not only because of the smaller routing tables that naturally result, but also because of the convergence domain restrictions there. We're making the convergence domain. Who needs to know about the specific network alterations? We're making that smaller. The smaller your convergence domain, the fewer people that you have to tell about a change, the more optimal your overall network design is. Well, we've talked about this hierarchical network model from Cisco. We said it was over a decade old, Well, it's time for us to go ahead and show you what the model actually is. Notice the model defines three layers. A core layer, often referred to as a backbone layer, the distribution layer, and the access layer. The access layer is often referred to as the desktop or the workstation layer. I prefer to always, and you'll see me always refer to these as these three terms: core, distribution, and access. And that's because I'm an old school Cisco person, and I am just always operating in terms of the kind of classic Cisco disciplines. So I don't use any of these newer, fancier nicknames that these particular layers have got, because for over a decade I've been calling them core, distribution, and access. Now, we're going to go through each of these layers and the functionality that is typical for each of these layers. But before we do that, I want to define each layer, and I want to impress upon you that sometimes there is the collapsing of layers. So sometimes, for simplicity, especially in a real small network, you might have an access layer and then you have a collapsed distribution and core. Yeah, that could certainly happen. But notice you still have the functionality of a distribution layer. You still have the functionality of a core layer. It just happens that they got sandwiched together and they are compressed into a layer that gives both the distribution and core functionality. The core layer is for the backbone of your network, and it is to move data as quickly as possible through your core network. So the very, very core of your network, where you're moving data from like your finance department to your marketing department to your sales department, where you have this just tremendous amount of traffic flowing in your own internal network. This is done across what we call the core. My mom's in real estate here in Florida, and she tells me that in real estate there's three things that are important: location, location, and location. Well, in the core layer of the Cisco hierarchical model, there's three things that are important, and that is speed, speed, and more speed. We are obsessed with high bandwidth, low overhead, speedy connections in the network's core. We actually refer to what we're attempting to do in the core as wire speed. If we have 10 gigabit Ethernet interfaces in our core, we're attempting to get those to send at 10 gigabits per second, trying to get things to a wire speed in the core. Now, certainly, we can't get to everything we want to get to in our own internal network, right? We have a lot of resources that we need to access that aren't local to us. In fact, it used to be an 80-20 model. It used to be that 80% of the stuff we wanted to access was local to us, 20% was far off. Well, this model certainly is starting to get turned on its head, and it's more like a 20-80. Seems like only 20% of the stuff we want to access is local, and like 80% of it is remote. And this is why the distribution layer just continues to get more and more critical in network designs. The distribution layer is that layer that gives us, as speedy as possible, speedy access to remote resources. The distribution layer is going to give us that speedy access to things that might be located out on the internet, or might be located at one of our corporation partners, or might be located at one of our branch offices. Now, how do we get people onto this beautiful network of ours? Well, that's the job of the access layer. And you can see why that particular layer ended up with the nickname of desktop or workstation in many textbooks, because this is where we would plug in are workstations. And when you plug in a workstation, what you see in a Windows environment certainly is what's called the desktop. So we get folks onto the network with the access layer. We get them to remote resources through the distribution layer. And for our network itself, all the stuff that we own, we're moving data as quickly as possible, or voice or video, over something we call the core layer of the network. When we talk the core layer of the network, we are, of course, alluding to speed, and more speed. We are trying to have things operate at a true wire speed when it comes to the core. Obviously, reliability is on our minds big time when it comes to the core. And remember, we talked reliability. That is, how often is that equipment functioning like it should? We talk redundancy when we talk about the core. And we'll talk about redundancy technologies later on in this chapter. This chapter will actually wrap up on day 2. This chapter will wrap up on day 2 with an intense look at redundancy technologies. We talked fault tolerance. This is tied to redundancy. And it means how quickly can we get back up and running. Obviously, sometimes, thanks to our redundancy technologies, we're back up and running seamlessly. Or to use the often used networking term, we're back up transparently. Something crashes in the network and the individuals that use the network are able to just continue to work like nothing ever happened. The core tends to be very manageable. We probably have tools from Cisco like Cisco Works helping us manage this important core of the network. One of the things that we love about the core is we do very little in there to give overhead. A classic example would be we tend to do little to no security filtering. Yeah, we don't need to security filter in here. We've already done it at the access and distribution layers, so we keep the security out. And the reason why we keep the security out is because we don't want the overhead that the security parameters, the security filtering might introduce. We don't want overhead because, as we stated earlier, we want to make sure that traffic is moving through this core as quickly as possible. We really be careful about the growth of the core. The core is something that's really finite. It's of a limited, consistent diameter, and we can add modules to the distribution and access layer. Typically, we're over-provisioned in the core. We have much more bandwidth than we actually need, so we keep the core of a limited and consistent diameter. We'll talk about that more later on in the course. And a very powerful ingredient that we're going to have in the core is quality of service. Okay, is quality of service. But the quality of service that we are going to implement in the core, it might not be the same exact parameters of quality of service that we would have at the edge. Quality of service is going to be one of our most sophisticated topics in this course. And one of the reasons that it is so complicated is that there's so much that makes up quality of service. Okay, quality of service is really, really a complex topic. Let me just quickly whiteboard for you just how complex it is. When we say quality of service in this course, we're referring to 3 overall approaches you can take to quality of service. There's best effort. And with best effort, what you do is you go ahead and over-provision. You go ahead and you add throughout your network way more bandwidth than you possibly need. Ugh. This isn't good, because this typically means that we are wasting some dollars along the way. But that's certainly a way in which to deal with quality of service. Do nothing. Just go ahead and over-provision the network and allow like first in, first out, for example. First packets in are the first ones to go out. If you're over-provisioned, that's no problem. The second major approach to quality of service is called the integrated services approach, or simply for short, this is called IntServe. The IntServe approach says, let's go ahead and reserve resources out there on the network. When someone picks up a voice over IP telephone, for example, let's have all the devices communicate with each other and reserve the amount of bandwidth that that call needs. This is all brought about by a very important protocol for the integrated services approach called the Resource Reservation Protocol, or RSVP. The third overall approach to quality of service is the most popular, and it's the one we'll focus on in this course. It's called differentiated services. Differentiated services means that we are classifying and marking traffic and treating it a certain way on a hop-by-hop basis. Differentiated services is made up of disciplines. We classify traffic, we mark traffic, we do congestion management with the traffic, we do congestion avoidance with the traffic, we do traffic shaping and policing with the traffic, we do compression with the traffic, we do link fragmentation and interleaving with the traffic. So notice there are many, many different aspects to this differentiated services approach to quality of service. And we might do classification and marking at our access layer. And we might do something like congestion avoidance at the core layer. So when I say that we have quality of service at all three of the layers potentially, notice I'm not talking about the same exact quality of service mechanisms. So thanks to differentiated services and the many, many aspects of differentiated services, sure, we might say generically that we're doing quality of service at all three layers of the hierarchical Cisco network model, but all quality of service is not created equal. We're not going to be doing the exact same differentiated services QoS mechanisms at the core that we might be doing at the access layer. At the distribution layer, here's where we're going to get into things that would add quite a bit of overhead. Because at the distribution layer, we're going to be implementing policy. Who can access what resources from outside of the network, for example? Because we're often attacked from the internet, this is where we're going to have a lot of security. Sure, we're going to have quality of service here like we did in the core. Sure, we're going to potentially have redundancy and load balancing here like we did in the core. But notice, of the things we discussed in the core, the only ones that are common to the core and the distribution would be like these three: redundancy, load balancing, and quality of service. Everything else, like we're doing a lot of summarization, we're doing a lot of policy routing, we're doing a lot of security, we're defining our multicast and broadcast domains, we're routing between VLANs, we're doing media translation, like from fast Ethernet to gigabit Ethernet. We're doing redistribution. All of these are unique to the distribution layer. Notice the value of the separation of functions is easier to understand, easier to troubleshoot, easier to manage. having different jobs occurring in these different hierarchical network layers really makes it easy on us. Think back to the modularity we would use when building a home. All right. The access layer. Well, the access layer starts out by us reminding ourselves that, yeah, we better make it highly available. And again, I will end this module in day 2. At the beginning of day 2, we'll end this second module, and that will take a look at a lot of high availability things that we do have at the access layer. Okay, so we'll focus on high availability at the access layer to wrap up this module. Here's where we do have a lot of security. And security that we see at the access layer is things like port security, ARP inspection, VLAN access control lists, and we'll talk more about these in this course when we are focusing on security. Okay, so we'll talk more about these security technologies when security is a focus in this course. We're doing things like broadcast control. Under quality of service, we're definitely doing things like the trust boundary. What devices do we trust for quality of service settings? How far to the actual desktop do we do classification and marking of traffic? We got to be careful that people don't try and denial of service us with traffic, so we often have rate limiting here. There's spanning tree protocol running to make sure our layer 2 is loop free. And we also have things here like power over Ethernet and the establishment of our voice VLANs. It's pretty neat when you plug in the IP phone to a when you take your voice over IP phone and you plug it into your Cisco switch, you can automatically put the voice traffic in its own unique voice VLAN. So voice gets its own virtual local area network. The IP phones need power, right, in order to function, and they can get their power right over Ethernet on Cisco Catalyst switches now. So, a look at the technologies and the definitions of our 3-layer Cisco hierarchical model. We're not going to abandon this model in the next section of the course. We're just going to expand upon it. So again, while this model of access, distribution, and core is over a decade old, and while it has been improved upon, it's still something that we absolutely have to master. Okay? Because we don't abandon it completely. We're just going to, in the next lesson, see how we can expand and improve upon it with something called the Cisco Enterprise Architecture Model. Well, let's wrap up this lesson with some exam review. Which IIN components can be found in all layers of the Cisco 3-layer hierarchical network model? Provide at least 2. So, if we think about those building blocks of the intelligent information network, which of those components can be found in all of the layers of the 3-layer hierarchical network model? Provide at least 2. I'm seeing our audience chatting them in right away. Great job to our live studio audience. Yeah, definitely QoS and redundancy absolutely come to mind. Those are things that might end up in all 3 layers of the hierarchical network model. They don't have to. They won't in all implementations, but they tend to. Redundancy is definitely one of those things where it really is going to depend on budget. How much redundancy you have is directly going to depend on budget. We would want absolute 5 nines. We'd want full total redundancy in our environment, but it often comes down to, can we afford it? Finally, which layers of the Cisco hierarchical model are most likely to feature the use of security mechanisms? Oh, well, this is an easy one. Security mechanisms are going to be found in the access and distribution layers for sure. We tend to try and release the core of the network from any overhead or responsibilities when it comes to security. So I hope you feel like you have a good, solid, firm grasp on the three-layer Cisco hierarchical network model. In the next lesson of this course, we'll expand upon that model with the very exciting Cisco Enterprise Architecture Model.